I'll probably post 2 videos today. So on Friday we talked about our reference points for these parent functions that we have, right? And so the first one is 1, 1, and the second one is 2, 4. Good. 2, 1, 2, 3, 4. And with x cubed, which we're going to work with today, is 0, 0, 1, 1, and 2, 2, 8. Because 2 cubed is 8. 1 cubed is 1. 2 squared is 4. 1 squared is 1. Okay, so those are those magic numbers, and then we just reflect them. All right, functions, discovering inverses. I just need to get to here. All right. So describe the effects of the parameters h and k. Could we write, I think I'm going to skip over this one. I think I'm going to get right to here. We didn't talk about this, did we? Okay. Let's start here. So our vertical stretch is 3. Our horizontal translation on this one is, there is no shift, right? There is no shift, but it is going in this direction. Does that make sense because of the negative? Okay, good. And then if the negative was on the outside of the radical, then it would be going like this. Correct? It would be going down. And if you ever can't remember which is which, all you have to do is just substitute in a value for x. And that's what I'm going to do right now to double check myself. Okay, and my vertical translation is going down by 2. So let's start with that. What color? I'll use blue. All right, so I'm not going to the left or to the right because I have no horizontal. I'm going down 2. I know that that is, for lack of a better word, my vertex, right? That's my starting point. So let's just double check that it is in fact going to the left by substituting in, I think a good number would be, it's always 1, 1, and 2, 4, right? So if I were to go, but I have a vertical stretch of 3, so instead of going up 1 over 1, it's probably going to go up, over 1 up times 3, 1, 2, 3. That should be my next point, but I'm going to double check. So if I put in a negative 1 for x, I should get a positive 1 for y. So let's try that. So y equals 3 times the square root negative. I said I was going to put a negative 1 in, right? Well, negative times a negative is a positive 1. The square root of 1 is 1. 1 times 3 is 3. 3 minus 2 is 1. So I'm correct, right? So if I put in a negative 1, I get a 1. My next point should be over 2, up 4, 1, 2, 3, 4, but I need to do that 3 times, correct? Because we have a vertical stretch of 3. So instead of going up 4, I'm going to go up 12. So I would go over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Way up here. So it looks like that. Kind of crazy? All right, questions so far? Yes, say it again. Yes. Okay, I'm going to read it to you. This is saying 3 times the square root of a negative x minus 2. Does that make sense? So when I read it to you like that, it's saying 3 times the square root. Well, if I substitute in a negative 1, I get a positive 1. The square, then we have this. So this is saying I have 3 times the square root of 1. The square root of 1 is 1, so I really have 3 times 1, which is 3, and then I subtract 2, order of operations. Make sense? This is a multiplication problem right here. Okay? Good question. Kane. What is the graph? Pausing. Okay, so we don't have a verdict for y or what a radical function is in a modeling sense, but we'll find out. And then Essence asks, what's your question again? So normally our radical goes like this, right? Radical function looks like that. If it has a negative on the outside of it, it's the bottom half of the parabola that's turned on its side. Does that make sense? And then if it has a negative on the inside, it goes like this. And if it had a negative on the inside and the outside, it would look like that. Make sense? Because it's going in that direction and it's the bottom half. Say it again. The negative sign is on the inside. It's just a pattern essence that I've memorized, but the way you can find out is by substituting in a value for x and then finding it that way. That will tell you if you're going in the right direction. Does that make sense? So just always substitute in a value for x and it'll tell you which direction you should be going in. Well, I wouldn't substitute in 1 because there's no graph there. Does that make sense? If I substituted in 1, look what happens very, very quickly. And this was a really good question, and I'm glad you said it. If I substituted in 1, I would get this. Now, how come that doesn't work? Imaginary. Right? It's 3 times the imaginary number 1. Okay? So that's how you would know for sure that the graph is not going in that direction. Because when I substitute in 1, I get an imaginary number. Because it doesn't exist. The graph doesn't exist there. Make sense? The function doesn't exist there. So that's how you would figure that out real quickly if you're going in the right direction. Okay? You're very welcome. Okay. Look at this one. So there's 3 different translations happening here, correct? Okay. So I have a vertical stretch of 4. I have a horizontal translation of 2 to the left. And I have a vertical translation of 1 going down. So I'm going to left 2, down 1, left 2, down 1. I know I'm going in the positive direction, so normally I would go over 1, up 1, but I'm going to go 4 times that. So I'm going to go over 1, up 1, 2, 3, 4. Normally go over 2, up 8. I did this wrong. I shouldn't be going over 2, up 4. I should be going over 4, up 2. Why didn't anybody correct me? You wanted to see how far I would make a mistake? Okay. I don't know why I didn't catch that. Why, guys? Why is it over 4 up 2 instead of over 2? It's the inverse, right? We need to take the absolute value, the square root of 4, which is 2. Monday morning, right? So this one was down 2. I'm right with the 1. Over 1, up 1, but instead we're going to go over 1, up 3. 1, 2, 3. And then over 4, up 2. 1, 2, 3, 4. But instead of going over 4, we're going to go 3 times that. Sorry, instead of up 2. So I'm going to go over 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4. 1, 2, 3, 4, 5, 6. All right? I'm second guessing myself right now. What should I do when I second guess myself? Check with what? What number should I plug in? 1, 2, 3, 4. Let's substitute in -4 and make sure we're correct. Okay? So I'm going to substitute in -4, and I get 3 times -4 minus 2. And negative times negative is positive. So 4, the square root of 4 is 2. 2 times 3 is 6. 6 minus 2 is 4. Are we correct? 1, 2, 3, 4. 1, 2, 3, 4. We are correct. Okay? Teachable moment there. So it should look like that. That looks a lot better. Okay. So on this one, we are correct on this one. We're supposed to go over 1, up 4, and then over 1, 2, 3, 4. But instead of up 2, we're going to go 4 times that. 1, 2, 3, 4, 5, 6, 7, 8. We're graphing the inverse of a quadratic function, which is a square root function. Alrighty. Got this one. What am I going to do with that? Factor out of 4, right? Okay, I'm going to do this slowly. That's not good. Okay, so square root, I'm going to pull out the 4. That leaves me with x plus 3, and then minus 2. And Kane has decided that he wants to put parentheses around this so that he knows that that negative 2 is out there, right? Which is smart. I'm going to continue. When I take the 4 out, the square root of 4 is 2. So this is actually 2, a stretch of 2. It did. The square root of 4 is 2. Make sense? Okay, so I have a vertical stretch of 2. I have a horizontal translation of 3 in the negative direction, and I have a vertical translation down 2. I did. This way, 3. Make sense? Going to the left 3. So I'm going to go left 3, 1, 2, 3, down 2. There's my vertex. I have a stretch of 2. So instead of going over 1, up 1, I'm going to go over 1, up 2. Over 1, 2, 3, 4. Instead of going up 2, I'm going to go twice as much, up 4. 1, 2, 3, 4. What value would you substitute in to check? 1. Let's put a 1 in and see what happens. Because over 1, I should be up 2. Make sense? Yeah, you could put -2, then I should get 0. But I always try the second point, just to make sure that I'm on the right track. So if I go over 1, so 4 times 1 is 4, plus 12. 4 plus 12 is 16. The square root of 16 is 4. 4 minus 2 is 2. So I'm correct. Error 5. Awesome, Marin. Thank you. Okay, let's give you guys about 10 minutes to do your homework on this. And then we're going to go on to cubed roots. Okay? Are you excited? Okay. Make sense? Yep. Just like in quadratics, just in every single function we've done, H and K are the same thing. One's a horizontal stretch, one of them's a vertical stretch. Kane. I'm sorry, translation, thank you. For number 7. Let's look at it. Here's number 7. Is a graph. It's over 1, down 2, correct? And that scale is a little bit different. So automatically I know that this has a horizontal translation of 2. So I have x minus 2 underneath the radical. And then I have down 2, so subtract 2. It's going in the negative direction. It is 1, thank you. X minus 1, like this. But then it's going in this direction. It's going over 1, up 1, over 1, up 1, correct? So if it's going over 1, up 1, then I know my next point's going to be over 1, 2, 3, 4, up 2, correct? So it looks like that. So it doesn't have a stretch, but it is going in the negative direction. So it's going to be negative x plus 1. Does that make sense? Let's double check and make sure. How am I going to check? Christiana, how am I going to check? I'm going to substitute a value in. Let's substitute in 1, because if I get 1, I should get negative 1. Correct? If this function, if I wrote it correctly, if I put in negative 1, sorry, if I put in 1, I should get negative 1. So if I put in 1, I get negative 1 plus 1 minus 2. I think we did it wrong. You guys, I can't have everybody talking to me at once. Malik. Let's see. It's over 1, down 2, over 1. Oh, it's right. My vertex is wrong. It should be over 1, down 2, like this. This scale is different on here than it is. It's halved, so that's where I messed up. So it's still, so it should be here. And then over 1, 2, 3, 4, up 2. Am I right? I asked you guys if I was right before, and you said yes. So now it works? Over 1, down 2? Yes. Now it works. Because this is the square root of 0 minus 2, which is negative 2. So when I put in 1, I get negative 2, which is correct. There is, okay. So I'm going to ask you guys to put that away, and what? Reflection over the x-axis is down here, so that would look like this. Reflection over the x-axis would be down here. Reflection over the y-axis would be here. Okay? You're welcome. How much time do we have? 9:46. Oh, we've got plenty of time. Okay, everybody put that away. Nope, everybody put it away. Now we're going to do tonight's. This is really quick, okay? No. Everybody put it away. Please. All right, I'm going to stop this recording and start a new one.